All right, I'll do this both ways. Here's how I was thinking right off the bat. I was thinking this. That's the first step I was thinking. Okay, you all right with that? Okay, and then make it a single log like this. Right?
What?
Yeah,
How'd you get that?
When you change it from multiple logs to single logs, it's subtraction. What do? Divide. So I did was divide x squared by 4. Okay? All right? Okay. Now, what's the exponential problem? Coli. What's the exponential problem?
X squared divided by 4,
Equals what?
0,
No,
Four.
10,
not 10.
10, 7.
No. Come on, what's it equal? Come on, we should know this.
2 to 4.
What's the base?
4.
Oh my goodness.
X. Long.
Scott, say it again. 10 is the base. What's the exponent?
Yeah.
The answer's not 10, what I'm asking you.
No.
What's the other side? The base is 10, what's the exponent?
2.
100.
0. What's 10 to the 0? Isn't that how you change it from log to exponent? The base to that power equals that number, right? Oh, yeah. Isn't that what it is? Yeah.
Shoot.
What's 10 to the 0? Oh my God. One. I'm gonna take back all those times I said you guys are so smart.
Oh my god.
Never ended.
Okay?
Oh my god.
So, what do I do with the 4?
Multiple.
Multiply. What's 4 times 1?
4. You should know that.
X squared equals 2. X equals 2.
X equals 2, yeah.
Yeah.
Plus or minus 2, right?
Mm-hmm.
Are we gonna do this now?
Good job, Ryan.
Thank you, Jonathan.
Does the negative 2 work?
Maybe.
Can I go 2 times the log of negative 2?
No.
No.
So only positive.
So only the positive 2, right?
So if we leave the answer plus or minus 2, is that wrong?
Yes.
Oh,
Okay, but when you guys said this, I think it's easier. When you guys said to take that over, add it, so we could have 2 log of x equals log of 4, because 0 plus the log of 4 is just the log of 4, right?
Yeah.
Correct?
Correct.
All right? So then I could divide by 2, so then I'd have, wait, no, I'm gonna do that, never mind. That's even harder, or more time than I need to take. What can I do with that 2 like I did over here? Put it there, right? So I got log of x squared equals log of 4. If the log of this is equal to the log of that, what must be true about those 2 things? They're equal. So we're right here again, then, right? Down here. Okay? So maybe it might be easier if you have multiple logs on this side and you have a 0 on that side. You could put a log on each side, then you can just drop the logs and say whatever the numbers are equal. Okay? Either way, you're gonna get 2. All right, let's look at your answers for last night. 22 was 0.6, which would be what, 3/5 if you did the fraction. 24 is approximately 0.678. 26 is approximately 2.554. 28, you can just drop the two logs and just write 7x equals 2x plus 0.5 and then solve it, which comes out to 0.1, which is 1/10. 30 comes out to 310. I saw a lot of those were correct. And 32 comes out to be 2. Any of those you'd like me to go over? Cole?
32.
Sure. All right, so we've got
What was
log of x minus log of x over 100.
What was the answer to 28 again?
I'll tell you in a minute. And then what was the other side? Just x, wasn't it?
Yeah.
All right, you said which one?
28 was the answer.
28 was
Okay, where's that coming from?
0.1.
Yeah.
Well, okay, so on this one, I don't have 0 over here,
Good ass.
okay? If I had 0, if I added that log over there, then I could just say x equals x over 100, right? But I can't do that. So I have to put these two together. So how do I put these two together? Since it's subtraction, divide them. So I got this weird looking thing. X divided by x over 100, right? Isn't that what I got? Okay. When you divide by a fraction, it's the same as doing what, Olivia Wyndham? Multiplying by the reciprocal. So that's the same as x times 100 over x. Right? What happens to those x's? They cancel. So what we're saying is log of 100 equals x. Well, what base are we using here? Base 10. So I can just put in my calculator today, log of 100, which is 2. That's our answer. Okay? So whenever you divide by a fraction, multiply by the reciprocal, it'll make it look easier, you know, simplify it better for you. Once you get that, that's really easy now, right? Okay. Any others you wanted me to go over? Yes, thank you. 30. All right, number 30, log of 5x minus log of 15.5. What's it equal? Thanks.
2.
All right, so again, I've got multiple logs there. I want to make it a single log. All right, it's subtraction, so I'm going to do division. So I've got log of 5x over 15.5 equals 2. All right, so changing it now to a base 10, oops, sorry, to an exponential, the base is 10, right? I can say this number, 5x over 15.5 equals 10 squared. Remember, it's the base and that's the exponent, right? When I rewrite it as exponential. Well, that's 100, right? Well, how am I going to move that 15.5 over? Multiply, right? Which is 5x equals that. And then divide by 5. And I think that's where that 310 comes in, right? Someone check me on that. I think that's 310. Thanks. All right. Anything else? Okay, so we did exponential problems, right? We had something like, 3 to the x plus 2 equals 4 to the x minus, 1, let's say. What did we do to move those down? What did we do to both sides? We took the log of both sides, right? Then I could put the x plus 2 in the front, and the x minus 1 in the front. Take the log of 3 over to the log of 4. That's a number, okay? And then we have these logarithmic ones, which seem to give you guys issues, right? If these were addition, instead of dividing these to make it a single log, what would I have done to those? I would have multiplied them. That's the only difference. And then we rewrite it as an exponential. Okay? So we need to be able to do that. All right, today we're going to talk about the natural log, natural base of e. It says we're going to use the number e to write and graph exponential functions representing real world situations. And we're going to solve equations and problems involving e or natural logarithms. All right, so the natural logarithm and the natural logarithmic function is this. It says the compound interest formula is a equals p times the quantity 1 plus r over n to the nt power. Okay? A is the amount of interest that you earn. P is the principal. That's how much money that you put in if you were investing, I guess. R is your annual interest rate. We're going to write it. We're going to move that decimal point 2 to the left because it's a percent when we put it in there. Right, Trent?
Yeah.
N is the number of times interest is compounded per year. It might be monthly, daily, quarterly. Okay? And then T is the time in years. So how many years we actually did this. Suppose that $1 is invested at 100% interest, meaning our rate is 1. Compounded n times for 1 year is represented by this function. All right, so the rate was 1, n times, we don't know how many, and for 1 year, so n times 1 is n, Okay, so there's that function, okay? When you try to figure this out, when you plug in numbers for n, you get this graph. When n is 2, you got 2.3 or something. When n is 4, it's about 2.5. When n is 8, it's about 2.6. When n is 12, it's about 2.7. It gets closer and closer to this dashed line. We call that an asymptote. Remember we talked about that when we first started this chapter. We just said it one day and we didn't worry about it. But an asymptote is a line that a graph will approach but never actually touch. It's really, really, really close to it, okay? And this number, where this dashed line is like 2.7182818, and it just keeps going. It's like pi. Whoa. All right, now I think oops, I don't want to do that. I want to get back to my arrow. I'll move this back so you can see that. Okay. So this is an irrational number, like pi. It goes on forever, right? So that's what E is. Now in your calculator, you can find E in a couple places. All right. So E, if you look at your division button, there's a little E above it. So if I hit second, divide, and hit enter, it gives me that number. And it just rounded it here. It keeps going. All right? It's not repeating. Kind of looks like it repeats, but it isn't repeating. It just keeps going. All right? Another way to find it is this LN button, which we call the natural log button. We got our common log button and our natural log button. If I hit second natural log, it gives me e to a power. That's the one we're going to use most of the time for these problems that we run into. Okay, we're going to have some word problems, compound interest problems that has this letter E in it. Okay, so So that's what we're gonna use. And then if I go to the first power, that's e to the first, which is e, you get that same number. Okay, you don't have to memorize what it is, just know how to get it on your calculator, okay? So exponential functions with e as a base have the same properties as the functions you have studied, our other exponentials. The graph of f of x equals e of x, e to the x power, sorry, is like other graphs of exponential functions, like 3 to the x. Okay? The domain is all real numbers, and the range will be all numbers bigger than 0. You'll never get to 0. Okay, there's an asymptote there. All right, so again, it goes on forever. There's no repeating portion, like pi. All right, a logarithm with the base of e is called a natural logarithm. It's abbreviated as ln rather than log base e. So when you see ln on the problem, you could have written it as log base e. All right, natural logarithms have the same properties as log base 10 ones and other base ones. The natural logarithmic function is the inverse of that. So here's your blue one. That's your e to the x function graph. And this red one is your natural log. All right, they're inverses of each other. And they're always symmetric about that y equals x line. Again, I'm not worried about you graphing them. Okay? So we're going to treat ln just like we would log. All right? That's basically what we're saying. Just remember the base of ln is what? E. All right? So, same rules. I could rewrite this as log base e of e to the 0.15 t power. What did we do before when these were the same? They canceled. So what was the answer? Whatever that exponent was, right? So when you see ln e, the answer is whatever is there. Okay? If you see e to a power and ln is in that power, what happens to those? They cancel. But now what about that 3 that was there? What should I have done with that first? No, not distribute it. Put it where? As the exponent. So what's that answer then? X plus 1 to the third. Okay? That's the answer. All right? So if there's a number in front of the ln, or if it was, log base 8, that was 8 to the log base 8, there's a 3 in front, we move it to the exponent for the answer. How about, what's the answer to this one? Just this left part. There's 2 parts. The left part, what's that answer? 2x. The right part, x. So what's the answer to the whole thing? 3x. Very good. Yep, algebra's got lots of numbers. I mean letters instead of numbers, right?
It's all letters, there's one number.
Yeah, the 2, huh? Don't let it freak you out, Scott. It'll be all right. You're doing good. You're focused today. Tell Trent to focus. He's zoning out. So, Kennedy, what's that answer? John, what's this answer?
2.
Super sophomores. What'd you say? Not ln x squared, just x squared. The 2 goes here. So this is e to the natural log of x squared. So those cancel. All right? What's this one? Trent?
Oh, boy. Is it X plus 4Y?
Very good. So when you see ln and e together, they just cancel each other out. Okay? Simple. Don't overthink it. Okay? Only you gotta remember, if you have a number in front of the ln, where do you move it? To the exponent, okay? All right, here's our compound interest formula when it's compounded continuously. All right, the PERT. All right, so what goes in for P? 500. What goes in for R?
No, 0.0525.
Yes, 0.0525. What goes in for T? 40. So we just substitute in. Whoa, changing colors, my magic fingers. Okay, so watch. Let's move this over here so you guys can see. We're gonna go 500. All right, then we're gonna hit second natural log for us to get this e caret, because that's an exponent, right? It puts e caret in there for you. You see that? So we're gonna put 0.0525, and then you have to put times 40, because those are being multiplied.
Wait, where's the E again?
Second natural log, second ln, it's the button right under the log button. Again, natural log is when the log has a base of what? E, that's all it's saying. All right, so then we put it, hit enter. So in 40 years, $500 is $4,083.08. All right. Got that? So what do I put in this one? What's P? 100. E to the 0.035 times 8. So we're just using up the formula for those problems, right? So 100 second natural log 0.035 times 8. And we get $132.31. So that's not that much after 8 years, is it? How many cents was it? 31. Always go to the hundreds, right? Percent. Okay, that's it. Pretty easy day, right?
Yeah.
Okay, here's your homework.
Trouble.
Okay. I had my favorite and what is why?
I tried to do that on the